Hi, everyone. Thank you for joining us and welcome to Open Infra Live, the Open Infra Foundation's hour-long interactive show sharing production case studies, open source demos, industry conversations, and the latest updates from the global infrastructure community. We're live here on Thursdays at 1500 UTC, streaming on YouTube, LinkedIn, and Facebook. My name is Jimmy MacArthur from the Open Infra Foundation, and I'll be your host today. As mentioned, this is live, and we'll be saving some time at the end of the episode for Q&A. So please drop all your questions into the comments section, regardless of the platform you're on, and we will answer as many as we can after the presentations. Now, onto the show. We're seeing a dramatic transformation of the data center, thanks to advances in AI, HPC, and increasingly complex workloads. As open infrastructure adapts to incorporate everything from VGPUs to SmartNICs, acceleration management is a necessary step to help improve performance and efficiency in the data center. Today, we're going to be talking about the ways OpenStack projects Cyborg and Nova are rising to tackle these challenges, and then we're going to dive into a real-world use case. So we're going to kick it off with Alex Song and Bryn Zhang, both from Inspur, a gold member of the Open Infra Foundation, and Li Lu with Snowflake. Let's go ahead and get started. Alex, Bryn, and Lee, I'll turn it over to you.
Okay, Alex.
Okay, let's begin.
Please open your camera.
Oh, okay.
Please. Please start.
So let's begin today's presentation. My name is Alex Song, and I'm the PTL of Cyborg. I come from Inspur Group, China. Today, my colleague Bryn and my friend Lee will together to share the Cyborg project and the VGPU management. The content will include the Cyborg project and GPU management by Nova and GPU management by Cyborg. And the last is Nova vs Cyborg. Next. Cyborg is an OpenStack project aimed to provide a general purpose management framework for acceleration resources such as GPU, FPGA, NVMe SSDs, SmartNIC, and so on. Starting from micro version 2.82 usually, Nova support creating servers with accelerators provisioned with the Cyborg service, which provides lifecycle management of accelerators. From the picture on the right is the relationships between Cyborg, Nova, and placement. First, the Cyborg will report discovery the accelerators of GPU, FPGA, and NVMe SSD, and report resources to placement. Then Nova will schedule devices from placement. Then Cyborg will attach and detach devices for the Nova. Next. So this is the Cyborg architecture. Cyborg mainly contains three services: Cyborg API, Cyborg Conductor, and Cyborg Agent. The Cyborg API provides interfaces for communicating with other components. Cyborg Conductor connects the database to store device info, then report data to placement for scheduler. Cyborg Agent run on nodes that have accelerators and a period discovery accelerators and send data info to superconductor. The picture on right shows the service deployment. The Cyborg DB and Cyborg Conductor and Cyborg API were deployed on the controller node, and Cyborg Agent, Cyborg General Driver were deployed on computer node. Next. This is the Cyborg report device steps. So we should first set the device driver in the Cyborg agent group. We should set the enable drivers with Inspur FPGA driver, Intel FPGA driver, and NVIDIA GPU driver. Then get device info. Cyborg agent period about 1 minute. Discover the accelerators info of GPU, FPGA, SSD, and so on. Runs the device info. Cyborg agent send device info to Cyborg Conductor. Then Cyborg Conductor receive the device info and write changes to the database. Cyborg Conductor sync device info to placement for VM scheduling. The picture on right shows the Inspur driver will discover the Inspur FPGA device, and the Intel driver will discover the Intel FPGA devices. For the NVIDIA GPU, we will have two drivers about the PGPU, VGPU driver, and the MIG driver. The PGPU and VGPU driver will discover the physical GPU and virtual GPU, and the MIG driver will discover the MIG devices. Next. This is the PGPU management by Nova. So we should first configure Nova computer by specific PCI address. In the PCI groups, we should set the pass-through whitelist with address and the list of addresses. If using vendor and product ID, all PCI devices match the vendor ID and the product ID are added to the pool of PCI devices available for pass-through to VMs. So in the PCI groups, the pass-through whitelist will be set by vendor ID, product ID, or the vendor list of vendor ID and product ID. Then we should configure Nova scheduler. In the filter schedule group, we should set the PCI pass-through filter in the enable filters. Then we configure Nova API. In the PCI groups, we should set the alias with the vendor ID, product ID, and the address name, or the list of vendor ID, product ID, and address name. Then we should configure a flavor with OpenStack flavor set GPU property, the PCI pass-through alias with the alias name and the count of the devices. So finally, we should create an instance with GPU devices. I recommend OpenStack server create a server boot with images, flavors, and the instance name. So next, this is a VGPU management by Nova. So we should enable the GPU type for Nova computer. In a device, enable the M device type. We specify the GPU type. In device group, we set the enable the M device types with NVIDIA 35. If you want to support more than a single GPU type, you need to provide a separate configuration section for each device. So in the device group, we can set the the enabled device type with NVIDIA 65 and NVIDIA 36. Sorry. So we should set the device NVIDIA 35 with the device addresses, and set the device NVIDIA 36 with different device addresses. The device addresses is the GPU PCIe address. One device type can have more than one PCI addresses, but one PCI address only belongs to one device type. So from the configuration, we can see the 84 and 85 GPU will use the same NVIDIA 35 VGPU type. So that this is then we should configure flavor with OpenStack flavor set VGPU property resource VGPU with the count is 1, and create an instance with the virtual GPU devices by OpenStack server create with flavor and image and the instance name. If we create instance with a specific GPU type, we can define the custom traits that will correspond to each to a GPU type by OpenStack trait create custom NVIDIA 11. Then add the corresponding trait to the resource provider, matching the GPU by OpenStack resource provider trait set, custom NVIDIA 11, and the resource provider ID. Then amend the flavor to add the request trait by OpenStack flavor set property to treat color custom NVIDIA 11 required. Then we can create a VGPU VM with a defined trait custom NVIDIA 11. Next. So this is the MIG management by Nova. First, we should split the GPU A100 80 GB. The PCI address is 84, for example. Now into the GPU instance for different size with 1 G 10 GB and 3 2 G and 20 GB. Then add the device enable device type for a specific GPU type. So in the device groups, we should set the enable device type with NVIDIA 699, NVIDIA 700. So device NVIDIA 699 with the device address, and the device NVIDIA 700 with different device addresses. But the device types all come from one GPU device. If you have a second GPU 100 A100 80 GB PCI address is 3B on the same host and split into 1 G and 10 GB, multiple 3 and 4G 40 GB multiple 1. You need to provide a separate configuration section for each device. So the device group will be set with NVIDIA 699 or NVIDIA 700 and NVIDIA 710 and 2. Device NVIDIA, so we should part set the different device type with different device addresses. The create MIG VM is similar with the VGPU. we should set the flavor and then create the VM with the set flavor. Then we'll create the MIG VM. So next. Next is the PGPU management by Cyborg. The PGPU managed by Cyborg is easier than the Nova. We just set the agent set the device driver in the agent group with enabled driver of NVIDIA GPU driver. The NVIDIA GPU driver automatically discover all GPUs with different product IDs and addresses by the command LSPCI. Grip the 3D controller, grip the NVIDIA vendor ID 10 10D. In default, the driver will discover all GPU devices. We have the plan to add disable enable device interfaces to make the device available for VM. The link is the blueprint to complete. So next. Then we create a device profiles. The device profile is the combination of different types of accelerators to request when create a VM like flavor. The group of device profile may like resource PGPU with the count 1 and treat customer GPU NVIDIA. It means the NVIDIA device, and treat custom GPU product ID 1DB6, which requires 1 NVIDIA Tesla V100 GPU. All the list of the PGPU resource and retreats. We require the 1 NVIDIA Tesla V100 and 2 A100 GPUs. Then configure a flavor with the OpenStack flavor set GPU property accelerator device profile with the profile name, and create the instance with the GPU device by the command of OpenStack server create with flavor GPU and images and instance name. The picture on the top is the accelerator in the device profile help. You can see the name and the group is needed for the device profile. So next. This is a VGPU management by Cyborg. So we first should set the device driver in agent group with the NVIDIA GPU driver. VGPU discovery driver is NVIDIA GPU driver, same as PGPU. By the command ls system bus PCI devices, the PCI address and device support types. We can get all VGPU types of GPU. In default, we set the VGPU type with the first item from device support types. We support change it by Cyborg API and simultaneously execute period discovery task to report new data. Every GPU can be set a different VGPU type. So create a device profile with OpenStack accelerator device profile, create a VGPU DP with the resource VGPU, the count is 1, and the trait of custom GPU product ID 1DB6, V100D, and 1Q, and trait of custom GPU NVIDIA, means it's the NVIDIA device. As the device profile required, means the device profile required 1 NVIDIA Tesla V100 VGPU with 1 GB memory. As Nova only support allocate 1 VGPU for VM, so from Cyborg side, we also set the resource VGPU to 1 constantly. Then we configure flavor and create a VGPU VM is same as a PGPU. So next. This is the MIG management by Cyborg. So the MIG feature is NVIDIA A100 GPU. New feature it's better than the VGPU feature. So we should first set the device driver in agent group. The enabled driver is NVIDIA MIG driver. The MIG discovery driver is NVIDIA MIG driver is similar with SmartNIC, as it also has PF and VF. So by command ls system bus PCI device and PCI address group vert F, we can get all VFs of the GPU. So in default, we discover GPU A180 GB into 1G 10 GB multiple 7, and set the VGPU type with 1G 10 GB multiple 7. We number its 10 split combination, change it by Cyborg API, and simultaneously execute the period discovery task to report the changed data. So we create a device profile, OpenStack accelerator device profile, create a MIG DP, which resource VGPU and contains VGPU is 1, and trait is custom GPU product ID 20B7 and A100D3 40C required, and the custom GPU NVIDIA is also the NVIDIA device required. And this device profile required one NVIDIA Tesla A100 MIG with 3G and 40 GB memory. Thus the VGPU also we set 1 constant. Then configure the flavor and create a MIG VM is same as the VGPU. So next. This is the Nova and Cyborg interaction. So if we create a VM with a GPU by Cyborg, so the interaction will be Nova API first call the Cyborg to get back the device profile. The request group in the device profile are added to the request spec. Then Nova scheduler invoke the placement and get a list of location candidate. Nova conductor calls the Cyborg API to create a set of unbound ARQs for the device profile and return them to Nova. Nova matches each ARQ to the resource provider picked for that accelerator. The Nova computer calls Cyborg to bind the ARQ with the host name, device or resource provider UID and the instance UID. This is a synchronous code which prepared or reconfigured the device. Cyborg on completion of the binding, the successful bound or otherwise failed bound, called Nova to send the event. The Nova computer manager wait for the notification, then call Cyborg to get the resolved ARQs. Then the Nova label word driver use the bound ARQ returned from Cyborg, then code the to compress the PCI pass-through device into the VM's definition. Now, if there is any error after bounding has been eliminated, Nova must unbound the relevant ARQs by calling Cyborg API. It will then retried on another host to delete the unbound ARQs, for instance. So next. So this is our products shows of the pages. So the first is a device list. The list of device pages displayed the ID, name, resource pool, and host in use type, VGPU type, and vendor and product ID, and instance UID bounded of the accelerator. If the type of PGPU, the VGPU type is none, and if the type is VGPU, the VGPU type will display with the name, memory, and the count. So the NVIDIA 180 1 GB means every VGPU have the 1 GB memory. The NVIDIA 699 10 GB multiple thread, NVIDIA 702 40G means there are three 10 GB and 140 GB VGPUs. So that the picture below is the device VGPU type update. For GPUs that support VGPU, such as V110, we can display all VGPU type from device support type path. For GPU that support MIG, for example, A100, we enumerate all specified conditions. Now users can select the VGPU type and change. Cyborg API update the database and notify Cyborg agent to report the changed data. So next. This is a device profile management page. So the name and group, when we create the device profile, the name and group are needed. The type in group can be PGPU, VGPU, or FPGA, depending on the accelerators in your resource pool. Then we choose vendor, product ID, and numbers. We can add a group with another type of device for device profile. So for a VGPU device profile, we need to choose the memory. The number is 1, and the group length is also 1 because we limit a VM bound only one. Limit a VM bound only one VGPU device. So next. So this is a Nova vs Cyborg. For a PGPU device, Nova only supports create VM with one type of GPU, but with Cyborg we can support create VM with different types of GPU. For VGPUs, Nova should configure VGPU type and addresses, which is very complex. And need to start the computer service if we modify the configuration. But by Cyborg, we don't need to configure VGPU type and addresses. And we support the dynamic modify VGPU type without restart Cyborg agent service. For a MIG device, Nova manages the MIG device same as VGPU. But by Cyborg, we can also automatic discovery available VF and support the atomic split MIG without restart Cyborg agent. So next. So this is our works to be continued. There are a lot of BP's blueprint to need to complete. From Nova side, there are added support for VGPU for placement with accelerator and the usage of new owner Nova trait. We distinguish from resource reported from Nova and Cyborg. From Cyborg side, we have the disable enable device API. and the VGPU management support, and NVIDIA A100 VGPU management, and the support change VGPU type by Cyborg API. So next. So that's all. Thanks for your attention and question.
Thank you, Alex, Bryn, and Lee, for that deep dive into the Cyborg project. And a reminder, as the slide says, we will have a Q&A after the presentation, after the next presentation. So throw the questions in the comments and we will get to them as quickly as possible. Next up, we've got Dmitry Rabatyagov from Clora, another gold member of the Open Infra Foundation, and a long-running OpenStack-powered public cloud in Sweden. Dmitry, talk to us about Clora's journey down the rabbit hole with virtual GPUs. And first, did you take the red pill or the blue pill?
Yes, and Jimmy. Yeah, I guess we took both basically during this trip.
All right,
so
take it away, sir. Thank you.
Yeah, so as Jimmy said, my name is Dmitry. I'm the main leader of cloud engineering at Clora. And also I'm project team leader of OpenStack Ansible for the last couple of cycles. For those who have not heard about Clora, let me do a brief introduction. So Clora, previously named as City Network, is the European cloud provider. We provide a bunch of different services, including public, compliant, and private clouds. We're also certified according to ISO standards in information security, resilience, environmental protection, and quality assurance. So at the moment of speaking, we manage 6 public regions all over the globe, including EU, North America, Asia, and even Middle East. Next, please. So eventually we have a set of criteria we've defined that should be met by final implementation. Having proper and safe multi-tenancy is quite crucial for us, since GPU workloads can be obtained and released quite dynamically. Each time we must be absolutely sure that reusing same GPU is safe for our clients. Everyone loves to save money on things, and operations are not exception. So it's always beneficial to take into account operational costs whenever you bring in a new technology. Next, we don't want our users to think that OpenStack is too hard. So being easy to consume our services is another key. Majority of requests that were coming from our customers regarding support of GPU workloads were mentioning CUDA support. Such workloads were going to be used for AI trainings and machine learning mostly. However, we got some other requests as well to provide support of GPU-powered desktops, which are Windows-based, obviously. So we had to add it to the list as well. Next, please. Yeah, so now when I briefly explained our use case, I want to do some brief look on the market options, let's call it this way, and see what we have today. So there are 2 columns, as you may see. Left one, compared technologies that can be used for providing GPUs, and Cyborg falls already touched this ground. And on the left, we see, well, hardware vendors, bigger ones that provide GPUs, basically. So let's start with PCI pass-through. It's quite basic and most easy thing to operate from my perspective, and it's supported for ages now in Nova. So you basically taking GPU as PCI device and passing it to the delivered using device address. Then inside VM, it's just a regular GPU as you would see it on bare metal host, and you can even use open source drivers to interact with it. However, since user gets full access to the device, you need to ensure that firmware state is good and is not compromised once the device is released, and before allowing to reuse it, basically. So depending on GPU cards, there are options for adding external root of trust for firmware or locking ability for that to upgrade or rewrite firmware. it can be hardly automated, basically, and it's quite not that easy to operate. So operation costs might raise at scale if going through this path. It might not be an issue for private cloud at all, or for clouds with single customer, but I mean, ensuring that hardware is safe to reuse is quite a big deal for public clouds. Also, if you're not using PCI Express over Ethernet and don't have standalone rack full of GPUs, then you will end up with 2 GPU VMs per compute host at best, because you are limited with PCI Express slots, and you can't usually you cannot place more hardware GPUs into the same server. So it's quite a limitation. AcceleraV from other side can help with both of these issues. So you don't need to worry about firmware state, as GPUs that pass through domains are now virtualized. Well, you can use AcceleraV to make one big virtual GPU just for security reasons or to ease your operational life. It also enables you to split GPU into multiple smaller ones. Depending on the GPU model, license, or how crazy you are, you can get up to 32 virtual GPUs from single physical one. So you can utilize hardware in more efficient way using AcceleraV. But it's a bit harder to operate because you need proprietary drivers on hypervisors that allow you to slice GPU. And then you should also take care of creating these virtual devices and configure Nova and placement accordingly, unless you use Cyborg for that, obviously. But when talking about hardware vendors, NVIDIA looks like a most common pick across community, and thus most battle-tested with operators around who can give you an advice on how to do things, how to avoid some bugs or configure things in a better way or more optimal way. From other side, you should never forget about inconveniences that proprietary drivers bring with them, and extra cost on licensing if you choose to use AcceleraV. On the other hand, they propose to use AcceleraV kind of free of charge, and overall implementation looks a bit smooth on paper, but eventually, I personally don't know anybody who does run AMD in their production. So it's a bit hard with community support and with knowledge in the community. Some people say that it's a bit tricky to get their drivers, but to be frank, it wasn't super easy for us to get drivers from NVIDIA either, so I would say they kind of equal here. But the main reason why AMD was no-go for us is absent CUDA support, which is another proprietary NVIDIA technology. I honestly wish people were using OpenStack more, but yeah, we have what we have. Next, please. Yeah, so as a result, we've picked NVIDIA GPUs and decided to go with AcceleraV, but found ourselves on yet another crossroad. As since Ampere architecture, NVIDIA has introduced MIG mode in addition to more, I would say, conventional VGPUs. So you can easily switch between VGPU and MIG modes on supported GPUs. It's basically a command to one single command for NVIDIA SMI. But you should also keep in mind that not all Ampere series does support MIG. Main key difference is that MIG mode computational cores are statically allocated. So as a user, you're better protected from neighbors that share the same hardware code. But this also gives quite significant improvement in performance for computational workloads. However, if workloads also involve storage operations or utilizing CPU as well, which is kind of common, VGPU might give slightly better performance in the end of the day. It's also preferable to use VGPU when you have more than 4 VGPUs, basically, or 4 partitions on the same physical card. Worth mentioning that in MIG mode, you can create less partitions or do less slicing from the same physical card than with VGPU. Next. So, licensing. The most tough and complicated topic from all our journey, I would say. So there are a couple of license types that are available. That basically you can separate it, the ones that are designed for virtual desktops, for computational workloads, and that do support both. For all licenses, except the ones that are designed for computing, which are named VCS, are paid per user basis. VCS on its term is, well, at least on NVIDIA documents, it said that it's paid per GPU. And in fact, yeah, you pay per physical device. But at the end of the day, license must be applied on client side. So in fact, with VCS license, what you are receiving is just 8 client licenses. Well, it depends on GPU model and how much VGPUs you can get. But in general, it's somewhere around 8 licenses. Licensing on clients also means that guest VM must be provided with the license file and should be able to communicate to the license server and transfer some data to it. And that is performed by proprietary drivers that must be installed for each client. In case a license cannot be verified in time, your GPU will be throttled, virtual GPU. So after 20 minutes without license, you will get throttled FPS and CUDA operations. And in 24 hours, CUDA is fully disabled and you're logged to, if I recall correctly, it's something like 5 frames per second. So it's basically unusable for the client. On top of that, client can't fetch or update to the latest version of the driver on their own because you simply VGPU drivers are hidden behind enterprise portal, which is available only to service providers. So you need an account that is not easy to get, and it's not really easy to register outside of asking for a demo account, for example. Yeah, and eventually you might want or you might need to have an on-premise license server because yeah, because it's proprietary drivers and your client is connecting somewhere, so you might want to control where it's connecting, and you don't want for some data leaving premises, for example. Next slide, please. Yes, so how we basically do that? Well, we had to write a deep element, and we are building images for GPU-powered VMs, and we pre-install drivers there and place a license token. We also test these built images with a Tempest plugin to ensure at least basic functionality of provided drivers. Since we don't use Cyborg and use just Nova and placement, we've created a systemd service that does create a bunch of mediated devices or VGPUs in other words that are picked by Nova whenever needed. And of course, we have our own premise DLS server. It's 5 volt and accept connections only from public networks that we do own. But it's still far from being perfect solution because in order to create a GPU-powered VM that will be properly licensed, you need to use specific set of image and flavors. But as of today, it's not really possible in OpenStack to limit selection of images for given flavor. Another thing is that versions of drivers installed for hypervisor and client must be compatible. So upgrading drivers is quite a tricky process and might become a real issue at day 2 operations. Speaking about drivers, while they're packaged and you can install them with a preferred package manager, they contain version as a package name. So when you expect for package to be upgraded, it's just erroring out with a conflict. So you must explicitly uninstall older version of drivers and install newer one. And of course, doing that on hypervisor will require to remove all created VGPUs. And it's already possible to live migrate VMs with GPU since they're on newer kernel versions. But if you run in some older software, it might be still not possible for you. Also, if only one GPU type is supported, so basically you configured, you want to use only one profile for all GPUs, and you are not using Cyborg. So you will need to add a new device type into Nova configuration, because otherwise config sections are simply ignored when just one type is provided in the config. So it checks literally for lengths of available types. Yes, and eventually, with latest NVIDIA drivers that were released, I can't recall it was December or January this year. So they basically enable you to map multiple VGPUs from the same GPU. It was a limitation by NVIDIA previously, but we still a bit struggle to implement that and to make it working. Maybe because of placement limitations, or yeah, I'm not really sure at the moment of speaking, but we are trying to get this working now. Thank you.
Thanks, Dmitry. That was
sorry.
fantastic.
One last thing. I was talking about Deep Element and Tempest plugin. So we have open source them. You can check QR codes here and use them. Hopefully they will save some time for you and will be useful. So feel free to use report box and yeah.
Perfect. So I have a question. The licensing seems like a bit restrictive. Do you think the GPU licensing is going to loosen long term, or is that something that's here to stay?
So given we are talking about NVIDIA, I won't expect it to go anywhere. However, to be frank, licensing is quite unique to NVIDIA. So basically, if we will, well, Intel cards are not yet to come, so we are expecting for them. But basically, neither Intel nor AMD do not have licensing thing. But I think as long as developers will use CUDA instead of OpenCL or more free and open alternatives, yeah, they have their power to enforce licensing basically.
Interesting. Okay. So let's bring everybody else back on. I think we've got Bren and Alex and Lee and Xiping. All right, so we'll wait for them to turn their cameras on, but I'll go ahead and throw out the first question. Does Cyborg do the MIG configuration, or is that done manually outside of OpenStack?
I think it's outside of OpenStack right now. As like, but I what I heard is Inspur folks has implemented some API to help with the MIG configuration, and they will be contributing those APIs back to the community. That's what I heard.
Awesome. Okay, great. Let's see. Next question. Do they need at least Usuri on the host for Nova?
Is this a Cyborg specific question?
I believe so, yeah.
Yes, it at least user release. Because we start user release merge the Cyborg feature in Nova, and we can interaction with Nova management the VGPU instance. Okay.
I can't actually recall regarding just VGPU and Nova as well, but yeah, I think it was implemented not that long ago. So maybe before Suri, only like PCI pass-through will be available just on Nova. But yeah, to be frank, we have way newer release running, so I don't really know.
Well, if you want to use Cyborg before Usury, I think maybe you can cherry pick the Nova specific changes and then use Cyborg with it. But we used to have some adapters for it, but yeah, that will be another story. Yeah.
Okay. I think that is all the questions we have from the audience at this time. I don't know if you all have any closing remarks. If not, we will close it out until next time. And
I think you missed one.
oh, did we?
Yeah, there was one from Dewey Nguyen. Like, do we need additional license from NVIDIA to separate GPU to VGPU? That one.
Yes. Sorry, I didn't cover that one because Dimitri pretty much covered it on his slide. But Dimitri, do you have anything else you wanted to add to that?
No, I guess no. Except answer is that yes, you do need to have licensing to use VGPUs. So you can test. So if you are deploying and you want to test the functionality, you kind of can omit licensing for a while because it gets throttled only in 20 minutes. So basically, you have some time to test out if VM is working, if it's responding, if everything looks good. But at the end of the day, yes, you will need to license them to work properly.
Okay. We just had one more question come in the comments from Graham Moss. Does Cyborg also help with SRIOV network with MIG and pass-through hosts? I have no idea what any of that means, so I'm going to throw it to someone over there.
Brent, can you help with this?
Cyborg also help with SRIOV network with MIG and pass-through. We this way we will try it to do by this way, to do it by this way. It also works, but it's not friendly for the VGPU's instance, because if we want to migration an instance, we should detach the MIG GPU and then reattach it to another in another server. And this if we use the pass through, if we use this way, it's not okay for the instance to run. But it's support this way because MIG MIG configure MIG GPU and VGPU is all support SRV network.
Yeah, so I think what Brian mentions is that since MIG already support SRV pretty great, so Cyborg does support that. But if you do migration, he didn't suggest that you do the pass-through mode. I think SRV mode is recommended. If I understand correctly.
We've got one more coming in here from Andrew. I wonder if org will mandate developers to move forward from CUDA to OpenCL for AMD and Intel.
Yeah, I think it would be great, but at the same time, as far as I know, NVIDIA does quite a good job to motivate developers to stay with them, including giving like free cards for development purposes and yeah, doing trainings, learnings, and good marketing, basically. So I'm not sure if this is going to happen. At least I don't see any tendency in moving forward. Maybe when Intel will become a production ready scene, things will change. I hope for that, but who knows?
All right. Any other questions for each other? I know, Dimitri, you got anything for the Cyborg team while they're here?
No, I don't think I have any questions.
Okay. Well, we'll close it down. And I would like to thank everyone for showing up today, and thank you for the presentations. It was incredibly informative. If you ever wanted a deep dive into Cyborg or hear the trials and tribulations of NVIDIA VGPUs, you came to the right place. So thank you to all of our speakers, and we appreciate you joining us, and to the audience for some great questions. Stay tuned to Open Infra Live for announcements on the next episode. Meantime, please don't forget to join us June 13th to 15th for the Open Infra Summit in Vancouver. Registration is live and early bird prices end today. If you're interested in sponsoring, you can talk to me, Jimmy at openinfra.dev. And remember, if you have an idea for a future episode, we want to hear from you. Submit your ideas at ideas.openinfralive, and perhaps we'll see you on a future show. And finally, I'd like to thank the Open Infra Foundation members that make all of this possible. If your organization would like to join the Open Infra Foundation, take a look at openinfra.dev/join or give me a call. Thank you very much and have a great day.